Okay, I hope everybody's having a good day today. Today, we're going to be making our transition from the study of DC circuits to the study of AC circuits. A prerequisite to doing that is a review of the basic mathematics that's going to be necessary to carry us through our study of AC electronics. We're not going to have to get into very difficult math, but we are going to have to review both right triangles and basic trigonometry. And so what we're going to do is we're going to start off with the Pythagorean theorem, and we're going to review the Pythagorean theorem. Probably all of you have seen the Pythagorean theorem in high school. Those of you watching this on a distant ed mode may have seen this in school as well. But we'll do a review just so that the terminology that I'm using you'll be familiar with if you learned it a slightly different way. The Pythagorean theorem. Okay, that's the only time that I'll spell it all out the whole way. And you don't have to memorize the spelling. That's something that you're generally not tested on. But the Pythagorean theorem, stated mathematically, relates the sides of a right triangle. So if we were to draw a right triangle and we were to identify the sides of the triangle, the horizontal side of the triangle is typically in mathematics called side A. That's the vertical side and actually represents the length of the portion of the triangle that runs the horizontal length of the entire triangle. This angle right here is designated as a 90-degree angle by drawing a little box there. Okay, that's the convention in mathematics to show that it's a right angle there. The vertical segment of the triangle is usually designated with a lowercase b. It could be any letter, but that's just the convention that's used in mathematics. And then, of course, the longest side of the right triangle is the hypotenuse, and it's designated with the letter C. So the Pythagorean theorem gives us a mathematical formula that allows us to calculate any one side of the triangle if we're given the other two. Okay? You have to be given two in order to be able to use it. Okay? But if you're given any two, then you can find the other one. So if you're given the hypotenuse, you can, and let's say the vertical side, you can find the horizontal length. If you're given the vertical height and the length of the hypotenuse, then you can find A, or any combination thereof. So the formula for the Pythagorean theorem plays out like this. C squared equals A squared plus B squared. Okay? And that's known as a mathematical expression for the Pythagorean theorem. Okay? Now, when we're actually using this formula, the Pythagorean theorem, we're not going to use it in that form. And the reason we won't use it in that form is because we don't really care what anything squared is. We don't care what the length of the hypotenuse squared is. We want to know what the length of the hypotenuse is. Okay? We don't care what A is, or A squared is. We want to know what A is, and so on. So, as a result, if we wanted to solve for the length of the hypotenuse, given this formula from the Pythagorean theorem, then, of course, we could take the square root of c squared, and the square root of c squared would give us c. If we take the square root of the left side of the equal sign, then we have to do the same thing on the right side of the equal sign, And so C, or the length of the hypotenuse, would be equal to the square root of the sum of the squares of the horizontal and vertical lengths. So C would be equal to the square root of A squared plus B squared. Okay? And then in a similar fashion, we could solve that formula for any one of the variables that we wanted. In other words, if we redraw this, this original formula again, C squared equals A squared plus B squared, then we could just use simple algebra to isolate the A. Okay? And if we did that, then we would get that A squared is equal to C squared minus B squared. Okay? So if A squared is equal to C squared minus B squared, then by doing the same mathematical operation, in other words, taking the square root of both sides of the equal sign, we would get that the length of the side A is equal to the square root of the hypotenuse squared, the length of the hypotenuse squared, minus the length of the vertical side squared. Okay? So this is a formula that you definitely want to put in your reference book because it's a formula that you'll use over and over again. And then the variations of this formula, this being the first variation of the formula, you'll definitely want to put that in your reference book because if you need to know the length of the side A, then that's the formula that you're going to use. And then in a similar way, if we were to solve for the length of the side B, we would get the square root of C squared minus A squared. And so that would be probably the third most important formula if we needed to find out what the length of the side B was if we were given the length of the hypotenuse and the length of the horizontal side of the right triangle. Okay? So basically that's all we need to know in terms of the theory from the Pythagorean theorem in order to solve right triangles. Now you can ask the question, why do we even spend the time to do this? Who really cares? And the answer to that is that in AC electronics, we end up with a lot of different quantities like voltage and current being out of phase with each other. And it just so happens that in single-phase balanced systems, they almost always turn out to be out of phase by 90 degrees or less. And so that makes the right triangle a very useful tool in solving for the magnitude of voltage, the magnitude of current, the phase angle of voltage, the phase angle of current, and a lot of the other parameters and variables that we're going to be looking for in AC studies. Okay, so let's just do a quick test for understanding, or a check for understanding. Quick check for understanding. I'm going to draw a right triangle. Okay? I'm going to indicate on this right triangle that the length of the hypotenuse is 7 feet. And I'm going to indicate that the length of the horizontal component of the right triangle is 5.2 feet. And what I want to know is, what is the length of the vertical component of the triangle over here? So in other words, if we were to refer this back to our original diagram using the Pythagorean theorem, we're trying to solve for B. Okay? And so if we just simply write these formulas down or have them memorized, obviously we would be using this formula here at the bottom, and B would be equal to the square root of C squared minus A squared. And so what I'd like you to do as a check for understanding is just see if you can all get the same number. Make sure that you can get your calculators to work for you properly. Depending on which calculator you have, you may have to hit the square root button first, or you may have to do the calculation inside the radical and hit the square root button last. Okay, so so we got one of them, we got 4.7, and one of them we got 21.96. Now this is the place to make mistakes. Right. Now, one thing that would tell you that the 21.96 couldn't possibly be the correct answer is that the hypotenuse is always what? The longest part or the longest segment of the right triangle. In other words, neither the horizontal component or the vertical component can be as long as the hypotenuse. So if the hypotenuse is 7, everything else has to be less than 7. Okay? So we know that 21.96 can't be the right answer. Let's give it another couple of seconds. How are you coming there? Okay, so 4.7. So it looks like the correct answer is 4.7. So this is 4.7 feet. And that would be this length right here. And a lot of people like to think of this as a ladder leaning up against a wall. Okay? Because OSHA requires there to be a certain rise-run ratio so that the ladder doesn't fall down when you climb up it. Okay? And the Pythagorean theorem can be used to figure out how far you need to pull the ladder out or how high the ladder needs to be positioned up the wall in order to comply with the OSHA standards for ladders. That's just one example of a practical application for safety. Okay? Okay, let's go ahead and do one final example. And let's try to make this a little bit more practical. Let's say that we had a wall. There's a side of a wall here. This is a building. That's the side of a wall. Okay? And then this is going to be ground level down here. So we've got the side of a wall and we've got ground level. And what we're going to do is we're going to take a ladder and we're going to lean a ladder up against the wall and have it touch the ground at some point. Are we able to make that red out okay? Okay. Now, if this was a long ladder, and I didn't have a tape measure that was long enough to measure the ladder or the manpower to take the ladder all the way down. But on the other hand, I could measure the length of the run of the ladder, or the horizontal length, between where the ladder touches the ground and where the building starts. So let's say that I measured this right here, and this turned out to be 12 feet. Okay? And then in a similar manner, I came over to the side of the wall, and I found that this distance right here turned out to be 14.5 feet, or 14.5 feet. And then my question is, how long is the ladder in feet? Well, obviously we would use the Pythagorean theorem to figure that out. In this particular geometric diagram that I've drawn, which represents the pavement, a building, and a ladder that's touching both the pavement and the building, the ladder would be the hypotenuse of my triangle. This I would assume to be pretty close to a 90-degree angle. It's usually not going to be exactly 90 degrees, but it's close enough that we can assume it's 90 degrees. And if we look back at our Pythagorean theorem, C is equal to the square root of a squared plus b squared, which is equal to the square root of 12 squared plus 14.5 squared. So if I stick those numbers into my calculator, they should accurately tell me what the length of my ladder is. And so what do you get when you plug those numbers in? 18.82. So 18.8 feet. So that's almost a 19-foot ladder. Okay? So it has a lot of useful applications. We're going to be using the Pythagorean theorem in combination with some trigonometric functions that we're going to learn about, which may seem like big words and things that you may or may not have learned previously, but not difficult to work with once we simplify it. And we will combine the Pythagorean theorem with some basic theorems from trigonometry to be able to not only calculate, moving back over to my Pythagorean theorem diagram, to not only be able to calculate the length of either side or the hypotenuse, but to also be able to calculate the length of the angles inside the triangle. Inside the triangle, there are actually 3 angles. One of the angles is right here. It's the angle between A and C. Okay? And that angle is usually called theta. Theta. It's a Greek symbol. There is another angle inside the triangle, which is usually represented by the Greek symbol phi. P-H-I. Phi. Okay? And that's the angle between B and the hypotenuse. And then the final angle in the triangle, if it's a right triangle, is going to be this 90-degree angle right here. Okay? Before we leave the Pythagorean theorem, there's another point in geometry that I want to point out to you, and that is that in a right triangle, the sum of all 3 angles have to add up to a certain number of degrees. Does anybody know what it is? 180 degrees. So the angle theta plus the angle phi plus 90 degrees has to be equal to 180 degrees. So a lot of times that's helpful for us because we might know everything except for theta, and theta is what we're looking for. And so just by knowing this, we can then solve this for what the angle is inside the triangle. The other techniques that we use to figure out the angles inside of the triangle involve the study of trigonometry, okay? And that'll be the study of our next unit. Okay, so when I introduced this, I'd indicated that our point of study for week 7, part 1 would be right triangles and trig review. The amount of time that we spent on right triangles, we'll go ahead and move the trig review to our next session because we just don't have enough time to adequately address that. And so we're going to go ahead and, unless there are any questions, dismiss for the evening. Hope everybody has a safe drive home. If you have any questions, come on up and see me. Good night.